Today we're going to look at solving any multi-step inequalities, and we will have a special solution at the end. This is part 2 of these notes. Let's go ahead and get started. At the top of these notes, we should already have this filled in. We're going to distribute. I'm going to go ahead and practice this one time, this method, which we did on problem number 3. I'm also going to use our standard method that we have been using, and I'm going to use that on 6 and on 10. So we're going to add and subtract terms to each side. We're going to, of course, distribute, add and subtract terms to each side, combine like terms, multiply and or divide to solve for the variable. There is an inequality rule that when we multiply or divide by a negative, we flip the sign. Whenever we multiply or divide by a negative value, we have to flip this sign. And I'm going to give you an easy way to check to make sure that our sign is correct. So let's look at problem number 6 real quick. In problem number 6, we have 4 parentheses c plus 2 minus 3c is all less than 12. So my very first step is to distribute. I don't like parentheses. I want to get them out of the way. 4 times c is 4c. 4 times 2 is 8. Minus 3c is less than or equal to 12. In this case, because I do not have terms on both sides, I'm going to combine like terms and then solve as a two-step equation. My terms that are alike are this 4c and this negative 3c. 4c minus 3c is just 1c plus 8, because nothing happened with this 8. It is all still less than or equal to 12. For the sake of solving inequalities, you can treat it just like you're balancing equations. Whatever happens on one side happens on the other side. Instead of adding 8, I need to subtract 8. So c is less than or equal to 12 minus 8, which is 4. Here is my simple way to check. What is a number that is less than or equal to 4? One number that I love to check with is 0. I love checking with 0 because it makes things super easy. So if I check with 0, that means 4. I'm going to put 0 in for c. And if I put 0 in, 0 is less than or equal to 4, so this should work. This becomes, instead of c, it becomes 0 plus 2, parenthesis, minus 3 times 0. 0 plus 2 is 2. 3 times 0 is 0. 4 times 2 is 8. 8 minus 0 is still 8. Is 8 less than or equal to 12? It is. So my check works. So my answer, I know, should work because 0 works. So my inequality is facing in the right direction. If I was asked to show this on a graph, here's 4. Here's 3. Here's 5. 4 is where I start. It's equal to, so I color it in. And I shade less than, so I'm going to shade everything to the left. Anything that's less than 4. Any number that's less than 4 should work here. The next problem I want to look at is problem number 8. My very first step, as always, is to distribute. Here I have to distribute this negative. So this becomes 7y minus 6 plus y, because a negative times a negative is a positive, is greater than or equal to 10. Oh, I got to distribute here. So that's 10y minus 10. I'm going to use a similar method that I used over here. And I'm going to use it for a specific reason. You're going to see why. So that method, remember, was I identified all my variables. and I move them all. So this is going to come down, this is going to come down, and this is going to shift over. And remember, if they shift over, they change signs. So this is 7y, it didn't move at all, it stays the same. This y didn't move at all, it stays the same. This 10y moved over here, so it now becomes negative 10y is greater than or equal to. I move all of my other terms to the opposite side. Negative 6, I change sides, so I change signs. Negative 6 becomes positive 6. Minus 10 did not move at all, so it stays negative 10. I had 5 terms up here. I have 5 terms here. Now I combine like terms. 7y plus y is 8y. Minus 10y is negative 2y. Is greater than or equal to 6 minus 10, which is negative 4. To solve, I would divide by negative 2. And I'm left with y. Negative 4 divided by negative 2 is 2. Here is the issue with this method, and a big thing we have to watch for with inequalities. If we multiply, when we multiply or divide by a negative, we need to flip the sign. It was greater than equal to, it is now less than or equal to. Here's why that's important. Right now, we can think of an answer that is less than 2. Can we think of a number that is less than 2? My favorite number, 0. My favorite number to check with, 0. So I'm going to go ahead and plug 0 in for this. It should work. 0 times 7 minus 6 minus 0. Is that greater than or equal to 10, 0 minus 1? Sorry, my writing got a little cramped there. 0 times 7 is 0. Negative 6 minus 0 is still just 6. Is that greater than or equal to 0 minus 1 is negative 1. 0 minus 6 is negative 6. 10 times negative 1 is negative 10. So the question is negative 6 greater than or equal to negative 10? Yes. It's kind of weird to think about, but a 6-foot hole is not as deep as a 10-foot hole. Or you rather owe someone $6 than owe them $10. So negative 6 is greater than negative 10. And if I didn't flip my sign, I would be saying numbers that are greater than or equal to 2 work. 0 works, so this is correct. Again, you do not have to use this method. I just want to give you options. My final problem, number 10, I'm going to start by distributing. 3 times 2 is 6. 3 times negative b is negative 3b. Is less than 10. Nothing changes there. I distribute here. Negative 3b. Negative 3 times negative 6 is negative 18. Oh, I'm sorry, positive 18. What I'm going to do is I'm going to move this 3b. Well, first, I'm going to move this 3b. I have plus 3b. I'm going to do that on both sides, which means this zeroes out. I have 6 is less than. This zeroes out, and I'm left with 10 minus 18. I'm sorry, 10 plus 18, which is 28. So 6 is less than 28, which is true. But I don't have a variable. So what this means, because this statement is true, Unlike here where we had no solutions, here this works, which means this fancy symbol or saying all real numbers, which means every single number we can think about, every single number you've ever come across, 0, a billion, negative a billion, pi, every single one of these work. If you have additional questions, please come see me. Y'all have a great, wonderful day. Stay out of trouble, make good choices, be good people.